Hello, ladies and gentlemen, welcome back. And today we have our guest student, Taylor Swift, who wants to know what are mixtures and how can they be changed. Well, Taylor, stay tuned because you are about to find out. Before we can talk about mixtures, we need to talk about what is a pure substance. A pure substance is a material made of only one element or compound. The composition is always the same. In a pure substance, the chemical properties and many of the physical properties never ever vary. Your pure substances are going to be things like all of the items in the periodic table. Every single element is a pure substance because it's only that element found in the substance. Other pure substances are things like water. The physical properties never vary. The water that you see in this section of the glass and the water that you see in this section of the glass is exactly the same. However, in real life, most materials in nature are actually mixtures. By definition, a mixture is a combination of two or more pure substances that are not chemically combined with one another. No matter how well blended the substances are in this mixture, they're still separate molecules and they don't form new compounds. For example, let's mix together some sugar and some water. If you mix them together, the mixture will be a sweet-tasting liquid, but you'll not have formed something new. You've made sugar water, which is sugar and water, but you haven't made a whole new substance. Technically, there is a way to even remove the sugar from the water, and we'll get to those details later. Some mixtures are really easy to identify because you can even see the individual substances. Like if you put the sugar in the water and don't bother stirring, you can totally tell there's two separate things in there. Think about going to the beach. You see sand, pebbles, and seashells, and they're all mixed together. That's a mixture. Something like granola cereal. The pieces of raisins, nuts, and oats are easy to identify. They're mixed together, so it is a mixture. Let's take a peek at a little clip from Crash Course Kids to put all of this together.
Summertime is picnic time with sweet iced tea and yummy fruit salad. And ants. But still, yummy fruit salad. And hey, did you notice something? Those foods have something in common. They're both mixtures. Things made by combining two or more different things. Not the ants, they're just ants. But the iced tea and the fruit salad are mixtures. Anytime you combine two different things, you make a mixture. Whether it's strawberries and bananas, raspberries and blackberries, or cantaloupe and Legos. Which I don't recommend eating at all. I'm just saying it's a mixture. So let's have a little science with our picnic, shall we? Let's talk about the different kinds of mixtures we can discover. For example, if we mix sand and water in a glass, we'll get a mixture, even though after a while the sand will settle to the bottom of the glass. But if we stir some sugar into the water, the sugar looks like it disappears. But it really doesn't. The particles that make up sugar become distributed or spread around evenly among the particles that make up water. We call this kind of mixture a solution. Solutions have two main parts, the solute, which is the stuff that dissolves, in this case the sugar, and the solvent, which is the stuff in which the solute dissolves, in this case the water. Now, solutions can be made from types of matter that are in different states too. For example, the air that we breathe is made up of a solution of gases, mostly nitrogen, oxygen, and carbon dioxide. And soda water is really a solution of carbon dioxide gas and liquid water. But no matter what, and this is important, mixing things together in solutions does not make a whole new substance. Solutions can be separated again, back into the substances that made them. So, for example, if you leave the lid off a bottle of soda water, the carbon dioxide that's dissolved in the water will slowly float up to the top and bubble away. Given enough time, you'll be back to having plain old water in the bottle and carbon dioxide in the air as two separate things, not mixed together. So when you take a sip of your favorite fizzy drink, you're drinking a solution. But not all substances dissolve easily into other substances. The ability of something to be dissolved is called its solubility. Sand doesn't dissolve in water, for instance, so we say it has low solubility in water. But sugar dissolves pretty easily, so sugar has high solubility in water. Still, no matter how easily something might dissolve into another thing, you'll eventually reach the point where it can't dissolve anymore. Let's say you pour a whole bunch of sugar into a small glass of water. If you keep adding sugar to it to make it even sweeter, and who would blame you for trying, you'll get to a point where no more sugar can dissolve. The extra will just sit at the bottom. This is called saturation, the point at which no more solute can dissolve into a solution. Saturation happens when there's just no more room for the particles that make up the solute, in this case the sugar, to squeeze between the particles of the solvent, the water. Whew! All of this is making me snacky. Let's check out our picnic table again and investigate the different kinds of mixtures we see there. Let's start with the fruit salad. That's definitely a mixture of different kinds of fruit. Is it a solution? Nope, because the particles that make it up aren't equally distributed. I can dip my spoon in there and come up with nothing but strawberries one time, and then go back for more and get a spoonful of only bananas. How about the sweet tea? The solution to that question is that it's a solution. Particles of, say, water and sugar in the tea are evenly distributed in the glass. Every bit contains water and sugar. They're spread out evenly. Now, can the substances that make up our iced tea solution be taken apart again? Yep, if we heat the tea so that the water in the solution changes from a liquid to a gas, it evaporates into the air, leaving the sugar behind. So let's go over what we learned at our little mixed-up picnic. A mixture is made by combining two or more substances. When the particles that make up the substances are equally distributed, the mixture is called a solution. Solutions can be made of substances that are in the same state of matter, like gases in the air, or in different states of matter, like the gas bubbles in soda. The solute is the part of the solution that is dissolved, and the solvent is the part into which the solute dissolves. And solutions and some other kinds of mixtures don't always make new substances, even though it might look that way. Now, let's enjoy what's left of our picnic before the ants carry it all away.
Okay, so I hope you enjoyed that video clip and it helped explain a little bit more about mixtures. So let's talk some more about some of the things we saw in that video clip. To keep going, please turn over your notes and go to the solution section on the back. It does go better here. Sorry, having a brain fart. Okay, so here's all about solutions. Solutions are all the answers to your homework math problems, right? No, not exactly, sorry. Just kidding. Solutions are when the particles of each substance in a mixture are mixed evenly, just like you saw in the video. The most familiar kind of a solution is when a solid is dissolved into a liquid, just kind of like we saw with that sugar water. The solid that is dissolved is a solute. The liquid in which it is dissolved is called the solvent. As she said in the video, solutions can also be a mix of liquids, gases, or gases and liquids. For example, did you know the air you breathe is really only about 21% oxygen? The rest is actually nitrogen and other gases. Craziness. Another type of solution is called an alloy. An alloy is a solid solution of a metal combined with another substance. Haven't you ever seen a stainless steel sink or cooking utensils before? Stainless steel is an alloy. It's iron combined with chromium and nickel. Other mixtures are things like a suspension. A suspension is a mixture that contains particles that are large enough to be seen. For example, remember when you saw the sand in the water? They don't dissolve together very well, so it forms a suspension. The particles of the sand are too large to really dissolve and mix in. Colloids are suspensions that are not easily filtered because the particles are smaller. A really good example of a colloid is something like milk. You can tell if a solution is a colloid by passing a beam of light through it. When you see the beam of light, it's a colloid because the path is visible. Because the light is bouncing off all of those tiny little, invisible to your naked eye, it's bouncing off of all of those little particles. Okay, now you can go back to the front side about separating mixtures. Thank you. Separating mixtures. Because substances do not go through chemical changes in a mixture, they can be separated by physical methods. Some examples of separation by density. Think about when you get a box of Raisin Bran. The raisins are heavier than the rest of the bran flakes, so the raisins in the breakfast cereal tend to settle to the bottom of the box. Have you ever gone to the grocery store and seen oil and vinegar salad dressing, where you have the oil settling on top of the rest? You can see the separation of the substances. This is called density. This oil is less dense than all of the flavorings beneath. We can also use distillation. Remember when she talked about the iced tea and she said we can actually separate the parts back out? She's absolutely right. You can separate the solid and a liquid by heating it. By heating, I mean the liquid becomes a gas, so the solid stays solid, so you can separate the solution. This is an example of what distillation looks like. It's a pretty complicated machine. We can also use things like sifting by separating materials by size, using filter paper or screens. Have you ever seen a coffee filter before? It separates those large coffee particles from getting into your coffee. I mean, who wants to eat grainy coffee? Gross. Yay, you made it to the very end. Thanks for watching. As your reward, here's your explosion video clip that I know you've been looking forward to.